Visiting hackerspaces 3 to 5 years ago on Hack Across America, 3D printers were like the mainstay, and wow, do I have an awesome guest with us today to help me understand how the market and how the whole industry has changed. Ben, thank you for joining us.
Glad to be here, Dan.
So, from what I understand, Aleph Objects builds one of the most recognized 3D printers in the market, the ulzbot.
Mm-hmm. Yeah, we build ulzbot 3D printers. Yeah, so we have a couple different models.
And you've been with the company for now 3 years. You've seen this kind of take off, because it seemed like, from my perspective, from a consumer perspective, it was like the hot new thing on everybody's desk 3 to 5 years ago, front page of all of the maker kind of zines.
Right, and even like Wired and stuff. Right?
Yeah.
Yeah.
Where are we now versus where we were 3 years ago?
I mean, 3D printing as an industry has continued to grow rapidly. The market has changed a lot. It was definitely the hyped thing in the media for a while. There was sort of this everybody's going to have a 3D printer in their home story being told by the companies that were basically driving the growth at that point. That was a bit of a stretch. 3D printing is an extremely useful technology, and it's being utilized in many, many industries for just a ridiculous number of different things. Like, we have customers, printing end-use products. We have customers prototyping. We have customers doing jigs and fixturing, educational uses. I mean, just you name it. But there's still a learning curve in terms of learning CAD software. And for the most part, printers that people can afford print thermoplastics. So there's a limit in terms of what those materials are capable of from a functional standpoint. And so a lot of that sort of, it took the wind out of the sails of that whole 3D printer in everybody's home. But small businesses, big businesses, schools, research labs, and stuff like that have continued to adopt, during that time. It's just not.
Yeah, at the time it seems like it was almost being sold as this is the next PC revolution, where there's going to be a desktop on every desktop computer on every desk,
right?
In the same kind of fashion. And you touched on some of those stumbling blocks that have prevented that from happening. Be it the materials or the complexity of the CAD software and things of that nature.
The early printers also, they just didn't work very well. I mean, there were a lot of companies starting up where they had a good idea, maybe they had a good design, but they didn't know how to run a manufacturing company, or they didn't know how to support their customers, or they didn't have enough money to do those things. So people would buy a printer, they'd get a couple good prints out of it, they'd run into an issue, and then they were kind of kind of stranded, basically.
I'm in that camp as well, and I've tried numerous ones, and it's not that I don't love the technology, I just don't have the time to dedicate to fiddling. Not that I don't love fiddling, don't get me wrong. If I could just spend the rest of my life fiddling and hacking, I'd be a very happy person. But as somebody that needs to get stuff done. So do you think people have gotten burned, though? I mean, has the industry seen a slump because of that initial blip?
I don't know that it's people have gotten burned. It's just that the people that 3D printers are for, which would be the people that that have an idea and they know why they want a 3D printer, and they're making use of them. They've got the printers, they're running them every day, they're having good success. And the people that were buying them because of the media saying that they should buy one, a lot of them have said, well, that's not for me. There are also really inexpensive printers out on the market now that those people that are sort of on the fence can try out.
They're the easy bake oven equivalents, would you say?
Yeah, I would say in terms of output too. I mean, you're not going to get a really nice chocolate cake out of an easy bake oven. You're not going to get a really great functional 3D print off of a $200 3D printer. I'm sure there are people out there that would argue that they're.
It seems though the $200 3D printer a couple of years ago was it almost seemed like within the makerspace at least that was the goal. It's hey, let's find ways to build a design that uses as few components as possible. It's almost like there's a finesse to it, and we got some great results that required it's kind of like the compression of a novel versus a movie, right? One can tell a lot more texture, but it requires that much more processing by the human to read the entire novel rather than sitting and watching a movie, which is a 2-hour affair.
Sure.
And there you're done.
Yeah, I mean, I think it's a reasonable analogy.
Does it still hold true today? Because 3 years ago, if it was that I could get a $200 printer, but it meant that I would have to spend 10 hours building it and tuning it to actually get some decent output from it, and just figuring out the right amount of hairspray to use on it or whatever have you.
I mean, it depends on what people want to do. You know, a lot of our customers, for example, they're buying a ulzbot machine because they want to make a particular product or prototype or jigs and fixtures or what have you, and they need that printer to run, and they need it to run when they want it to run and do so reliably. That's a totally different need than somebody who's buying something just sort of as a novelty. And they're saying, well, I'm kind of interested in 3D printing, but I don't really know what I'm going to do with it. Maybe I'll print some trinkets for my kids, or some Christmas gifts or whatever. If their printer fails, their business doesn't fail with it. And so that's kind of like that's kind of become like a dividing line in the desktop 3D printer market. There's the printers that are sort of for fun, and then the printers that are for work. And so we definitely fall in the latter category. Not to say that people don't do fun things with their ulzbots.
Describe to me, what would you say the ideal user of one of your 3D printers is? Like,
either, I mean, in general, like I said before, like a person that knows why they want a 3D printer and what they're going to do with it.
So maybe they've had other 3D printers in the past. And they
Yeah.
know how to work CAD software.
Exactly.
Like,
So a lot of people that buy ulzbots have owned other printers in the past. Like a lot of them have, for example, been RepRappers in the past, and they built their own RepRap out of parts, and it worked pretty well. But they're always tinkering with it, and that led them to a path where they're like, okay, I've opened up this Etsy store where I'm selling these designs I made, but I can't rely on this thing to crank them out reliably. So that's
you've paid your dues tinkering.
Right.
Now you're actually producing something with it, and it's on the line. It needs to function reliably.
And then on the flip side are people that buy the ready-made 3D printers that are inexpensive, and those, particularly if they're not open source hardware, once they break, you may be stuck with a paperweight once it breaks.
Okay, so talk to me about that kind of audience, that community that is the makers that use these products, because I know that there's a lot of creativity in that maker community, but there's also a lot of one-upsmanship. There's a lot of like, ooh, I see what you did there, I can do it better.
Yeah.
How does that actually play into the design of the ulzbots?
Because we're a totally open source hardware company, it plays really well. So we have some users that basically say, well, I don't like the way you engineered this particular component, and so they fix it. But the cool thing, because we share everything we do, they tend to share those fixes back. So if you go like on the ulzbot.com forums, you can find post after post of people that have made mods and tweaks to their machines, and then people will take those mods and tweak them even more, and they're improving the hardware for how they want it to work, which they should be able to do.
Right, because what generation are you in? And it's hard to say because it's almost like it's rolling, right? Like what version of the ulzbot are you on now?
Well, the Tazz platform, which is our flagship machine, we're on TazzSixes now, which is actually I think the 7th version, because there was I think there was a 2.5 in there somewhere.
Oh, so, I thought you were going to say because you started with 0, as we all obviously should.
Yeah, no, I mean, right, yeah, we should.
Hey.
But
but nobody wants to buy the like Tazz 0. We think it might. Yeah, you notice it's always like the Nexus 1, the Pixel 1, like.
So no, we didn't start at 0, but so we're on the TazzSixes now.
But it's not the same. Like if I bought a TazzSixes now, it wouldn't be the same one necessarily as the first TazzSixes. If there's little minor improvements and stuff from the community that gets adopted, right?
We make minor improvements along the way, but more or less, we save those big changes for when we do a full rev. So we might. There might be some community improvements that we roll into the next full rev, but like a TazzSixes is more or less a TazzSixes, with the exception of changes that we make to fix. Like if there's an actual problem, for example, like if we're getting reports in the field that some component is breaking or something, then we would fix that midstream. But otherwise, we don't really roll improvements in the middle. And the main reason for that is support.
Right, because you're actually engineering a product for like manufacturability and supportability, which are totally different concerns than making a one-off really good design.
Right, right.
Yeah.
Yeah, so if a customer calls in and they say, hey, I've got a TazzSix and this is what's happening with it, we have to be able to say, oh, okay, well, we know exactly what you've got. And if it's got, you know, if we have to keep track of a bunch of mods that we're making during, right, yeah, it'd become a nightmare pretty quick.
Now, you'd mentioned RepRap. That's the concept that the machine can build itself. And you guys actually do that, from what I understand? Like you have machines that are running 24 hours a day making your own machines? We
do, yeah. So RepRap was a project that came out of the University of Bath, England. Started in, let's see, I want to say 2006, 2007. Our company started in 2011 with RepRap as an inspiration. So from the very beginning, we've been printing components to build our own printers. Currently, we run 155 machines, both TazzSixes and Minis, 24/7 at our factory in Loveland, Colorado. So those machines just are churning out parts all day long. Those parts are then QC'd, sorted, and then they go down to the manufacturing floor where they're used to build more printers.
So TazzSixes are building TazzSixes.
Right.
Do you find that, okay, so speaking of manufacturability though, is there a reason behind that? Like, do you find that more cost effective?
It's, the break-even point for injection molding, we're probably right about there. Like, we could probably say, okay, let's get injection mold tooling made and stop this, you know, 3D printing all the parts nonsense. But there are two reasons we don't. One, I mean, the cost is sort of negligible at this point between the two.
Well, it sounds like you've scaled it if you have 155 running 24/7.
Right, right.
Yeah.
But also, it gives us flexibility. So, like I said before, if we find out that there's an issue with a part midstream, we can fix it
like that.
Yeah, exactly.
Yeah, those tools are expensive. Like, most people don't think about this. You know?
Right.
Even when we design, you know, like the packet squirrel or the lantern or whatever have you, and you're like, you know, it's like $20,000, $40,000 for this mold that can only make so many units.
Right.
And it's a lot of upfront cost stuff.
Yeah, and if we were to go and get all the parts on a Taz, you know, get tooling made for all those, I mean, I imagine we'd be looking at, you know, $200,000, $300,000, $400,000 just for the tooling.
Right. So you would save a few cents, but it would lock you in to not being able to move as quickly.
Exactly.
I know at least when we go to design something, we use 3D modeling and 3D printing to make the prototype. But then we say, okay, cool. Well, now since we need to take this in mass, and that's why I ask, because we talk about, hey, where has the industry gone from 3 years ago to now? And it seems like it really has gone to mass because, like you said, like if the goal of, you know, the mindset 3 to 5 years ago was like, hey, let's make a $200 3D printer that doesn't suck and take 12 hours to make. Yeah. How is it now? Like, if I wanted to buy something that just works off the shelf for a couple $100, is that available today?
Yeah, yeah. Well, wait, for how much?
I don't know, a few $100.
I mean, so I can...
What I'm getting at is, do you see this becoming a commodity? You know, because we were talking about, like, is the PC era, is the like initial PC era of like, oh, you know, a machine on every desk. Is that applicable here?
I don't think so necessarily. I mean, in terms of like buying a machine that works reliably, yeah. Like part of the other benefit of running the cluster is that it's sort of dog fooding to the extreme, because we're using our machines as a production process. And so it's like we learn a lot about how the machines work and we can work the bugs out. So if we, you know, roll an innovation in and test it in the cluster, we can get thousands of hours on that new design before we ever even consider making it a product. So the printer itself at this point is extremely reliable. Most people can pull a Taz out of the box, you know, put it together. There's like a couple thumb screws you got to put in.
Right. I just watched Shannon do it in like less than an hour.
Right. It takes less than an hour for a Taz. For a Mini, it's like 20 minutes and you're printing. And so the printers have like a self-cleaning nozzle. They're self-leveling, so you don't have to monkey around with leveling the bed. They have a PEI print surface, which is heated, so you don't have to put glues and tapes on the bed. So most of that stuff is pretty.
Those were a lot of the annoyances. Those were a lot of the like, oh, well, you got to know the the guy on the forum that knows the tweak to make the thing work.
Yeah. So now it's take it out, put it on the table, load your CAD into Cura, ulzbot edition, and more or less hit print, and the printer takes care of the rest.
It takes care of that. There still are issues that can come up. What do you see those being? Like, what would you say is still like? So it sounds like a lot of the stumbling blocks, self-leveling, the heated bed, those things are taken care of. What are the next stumbling blocks that need to be solved, regardless of whether there's a good solution today? Like, where do you see this? In 3 to 5 years, what needs to be solved to make this really mass?
Well, one thing is like people that understand fused filament 3D printing. They generally know how to position things on the print bed and how to design things so that they'll print successfully. You shouldn't have to do that, right? Long term, you should be able to say, I want to print this shape that I concocted, send it to the printer, and walk away, and know that the printer is going to make that shape regardless of how you position it on the bed or how you designed it. Because in general, with a single nozzle 3D printer, you're still subject to gravity. So as an object is being built, if nothing is underneath it, it's just going to fall.
Right. So we either need smarter software that knows that the teacup needs to be upside down, or right side up, or whatever it is, or we need to solve the gravity issue, which you guys are working on, right? I'm assuming.
Yeah. So the auto orientation thing isn't quite. There's got to be a little bit of human involvement there. Like, print the teacup.
Well, you say that, and you look at going from Microsoft DOS in the '80s to an iPad, and the amount of ways that a user can mess it up. Right?
That's true. I mean,
it's constantly saving you from yourself.
Yeah, I do think there are like algorithms in the slicing software that look at the model and say, well, let's see, there's an overhang here, here, and here, but if I print it this way, it won't be a problem. I think that will come. But the other thing is better support material. So one thing we're working on right now is a dual extruder dedicated for doing soluble support. So you've got one nozzle that prints your object's material and the other nozzle that prints support that melts away in water. So
that opens up like a world of possibilities in the designs you can do, because you're not like sitting there cutting off pieces of plastic. Right.
And one of the designers that works for us, he's on the marketing team, and he does does sample models for marketing purposes and things like that. And it's already changed his thinking. So now Dave's like, instead of thinking like, well, let's see, I'm gonna have to split this model in half and then glue it together at the end, otherwise it's not gonna work, or it's not gonna look good. Now he's just like, load it in Cura, hit print, and it prints the supports for him, and dunk it in water, and the underside looks as good as the top side, which is what you want.
So what are those extruders? You said the dual extruders. Like, what's that actual hardware look like?
It looks just like a single extruder, except it's got two nozzles at this point. Yeah. So you've got two different motors that drive the filament out.
So is that something that's like an option when you're going to buy a ulzbot, or is it like an aftermarket thing? How does that work?
Yeah, we have a lot of different optional tool heads for the printers. So you buy the printer, it's got the stock single nozzle tool head, but we've got tool heads for printing flexibles and tool heads for printing. We've got one tool head called the Moore extruder, M-O-A-R extruder. It's got a 1.2 millimeter nozzle versus the 0.5 millimeter nozzle that we usually have. And so that thing can just hog out the plastic. So you can end up taking, for example, like something that would have taken 12 hours to print, you can print that in 2 hours.
Just low resolution.
Yeah, it's not going to look quite as good, but if you're printing like big structural things or jigs and fixtures, or we have one of our favorite sponsored ulzbot users is James Bruton, X-Robots UK. If you haven't seen his YouTube channel, check it out. But he recently broke a Guinness World Record by printing, I think it was like a 16-foot tall self-portrait of himself with a Moore extruder. So he had like, I think 2 or 3 printers running Moore extruders, and he printed this gigantic statue.
That's insane.
And doing that on a Taz with a standard extruder would have taken him weeks and weeks and weeks.
Now, we were talking a little bit before the show about some of the popular modifications that people make. They like to, it's an open platform, right? So people can swap out components as they see fit. E3D is one of those popular vendors that makes extruders and hot ends.
Yeah.
Now, help me to understand this market and how open source plays into it. Because from what I understand, they had an open design, but it was non-commercial.
Right, right, yeah. So E3D, they've been around for a long time in the RepRap industry, which is not a long time in geologic terms, but they make great hot ends. They were the first company making all metal hot ends, which enable printing higher temperature materials and just better temperature control and things like that. Like you said, for a long time they were open source, but their licensing was non-commercial. And so for us that was problematic because, like, well, we're a commercial entity, so we can't then, we can't share that file along with all the other things that we share, which are under totally free licenses. And so we couldn't work with them, basically. It was what it boiled down to. So as a result, our printers were arguably not as good as they could have been. And E3D wasn't getting all that revenue from us buying a hot end for every single printer we sold.
Right, so it sounds like a match made in heaven.
Right. So fortunately, earlier this year, they dropped the NC clause, and now we're working together and developing toolheads around their hot ends and extruders.
I find that fascinating how a company can scale completely open source as you've described it. How has Aleph Objects scaled as an open source company? Like, you've been with them for 3 years now.
Yeah, yeah.
And you said that now it's over 100 employees.
Yeah, when I started, it was somewhere between 25 and 30, and now we're about 136 people. And we run the entire company on free software, and we share everything that we do, from CAD designs to bills of materials to shop floor layouts and production processes. All that stuff is shared freely. And it's basically, I mean, it's scaled remarkably well. One nice thing about using all free software to run a company is that you don't have to, you're not like buying more software licenses as you add people.
Right.
So that's helpful. Like all of our workstations run, I think they're all on Debian Stretch now. And then we use a free software ERP system. ERP is Enterprise Resource Management.
Okay.
Or Enterprise Resource Planning.
Got it.
Management does not begin with a P.
Sure, sure. But all of your project management software, basically everything.
Everything
from the design side, the engineers using the CAD kind of software,
they use free,
to the support people using the customer relationship management stuff.
Right. Yeah. So our R&D department uses FreeCAD and KeyCAD and Blender. Our creative team, creative and marketing, instead of proprietary suites, we're using like Inkscape and Scribus and GIMP and Blender to do all of the same things that other companies would do with proprietary suites. So it's a challenge, but the way we look at it is that it would be it would be a little two-faced to say, on one hand, we expect our vendors to share everything under free licenses, and we share everything under free licenses, but we're cool with like buying software that doesn't respect user freedom.
Okay.
And it's also so that, like, if say we're sharing CAD files for a printer online, right? Say it's like just all the CAD components, CAD designs for the Taz components that are 3D printable, and somebody wants to modify one of those. Well, if we design that in a proprietary engineering software, in order for somebody to modify it, they have to have that proprietary engineering software. Whereas if we design it in FreeCAD, they can download it, they can download FreeCAD, they can make their modifications, and it doesn't cost them anything. And it also doesn't, they're not making compromises in terms of like sacrificing user freedom, which is like what we're all about. So
where do you have to make compromises? I know that you said that a lot of the components obviously are inherently open, but you've got things like stepper motors, for instance.
Yeah, and stepper motors, certain components of the printer, there's we do have to make compromises on some of that stuff. It's like some of those things are more or less commoditized, though. Stepper motors being one of them. Like a stepper motor from one company is more or less the same as a step promoter from another company, excepting maybe quality. So we look for the best components we can find in those situations, but we're, those are situations where we really don't have a choice.
Yeah, it's always tricky when you try to do like the full open thing, because right now it almost seems like, it's really awesome that you're doing this, because I'm always curious like how companies can make it on selling free, making up in volume, haha. But it's a beautiful thing to see like people actually testing this concept. And then you realize the stumbling blocks where you don't actually have any other choices. Like I'm sure everybody in the company has a cell phone. Is it an Apple? Is it an Android? Like,
we run Nexus phones, and they're running OmniROM and then F-Droid for the App Store.
That's awesome.
So our company phones are
that is really cool.
Are totally they're as free as we can get them.
Yeah, that's the beautiful takeaway there. Is as free as you can get them, because as free as we can get it today is different than as free as we can get it tomorrow. We have issues where certain things are inherently locked down because of the industry and because of the nature of like how those industries have come to flourish, like the chip industry, for instance. So even though your phone is running open source software, which is awesome, it's still got a Qualcomm baseband in it, or a Samsung baseband in it, which is a little black box. That's
and I mean, so our bet and our hope is that by growing the company, by staying committed to to our philosophy when it comes to like free libre open innovation, that it will influence others, and we are seeing that happen.
That's cool.
Like E3D is a good example.
And they've obviously had to make a decision where it's like, okay, they've weighed all of the risks and stuff, and they've said, actually, this is the best course of action for us.
Right.
So who are your mentors then?
Richard Stallman is definitely a big influencer. So we pay a lot of attention to the Free Software Foundation in terms of sort of basing a lot of what we do on what would Richard Stallman think, and that that restricts a lot of what we do right out of the gate. And we actually have Respects Your Freedom certification on our 3D printers, which there are very few hardware products, and no other printers have Respects Your Freedom certification. And then there are other companies doing things the right way. In our opinion, like Red Hat is a really good example of like a major software company that is completely dedicated to free development. So I mean, they've got like the Red Hat patent promise, for example. So they have patents that they've acquired by buying other companies. I'm pretty sure they've filed for some themselves, but they've committed to those being purely defensive. So, and they've got a public statement about that. We will not go after any companies that infringe on these patents, provided that they are also sharing their work freely, which is perfect. I mean, it's like sometimes you've got to figure out a way to work within the system that isn't necessarily designed to support that kind of collaboration.
Yeah, it's an interesting social experiment in addition to, it's an economics experiment, it's a social experiment, it's a software experiment, and I've seen it flourish in so many different ways, and you just wonder like, okay, well, where are we going to get to that like Star Trek world where, we have the replicators that just make the things, and you don't have to worry about famine or working or any of that. Everybody just does stuff because
just
they
lounges around and
well, no, they don't though. They explore the universe.
There we go.
Because they want to,
Yeah, exactly.
Yeah, because it's the right thing to do.
Right.
That just drive.
And that's, I mean, right thing to do is definitely like, that's the way we look at the way we do business. It's like, it's the right thing to do, but it's also the smart thing to do because we're saving money up front on a lot of things like software licenses, but we're also, we've built an incredible community. Like our, anytime on Reddit or in various other places online, when people ask questions about, well, which printer should I get? I want the most reliable printer I can find, and there's always like a line of ulzbot fans that just chime in, get a TazzSixes, I have one and I love it. And that's like, you can't buy that kind of loyalty, but by basically by giving back, I think we've earned it. So that's, it's pretty awesome.
Cool. Well, you know, we seldom, and I say seldom, I mean outside of doing like coverage of consumer electronics at CES or something, we never have vendors, as it were, on Hak5. It's not really part of our ethos either. But I'm very happy to have you guys on here, and I trust Dave implicitly when it comes to this stuff. So when Dave says, "Hey, this is the printer," and he's, Dave Randolph, he's that guy on Reddit as well that you speak of. That's like, oh, this is the thing.
Yeah.
So I'm just like, by the powers of the powers of intrinsic things, I will also say I'm stoked I want to play with one of those.
Cool.
Yeah, because I've also done the futz for 20 hours, get something to print once, and then never print anything again because it broke again.
Yeah, I mean, a lot of people that work for LF Objects were RepRappers back in the day, and myself included, and it's funny to think about what 3D printing stuff was then versus what it is now. Because then it was a lot of like futzing around with things and trying again, and oh, it's working this time, and
Right. It almost seemed like it was like, hey, it was like Woz showing up with a PDP-11 or something and getting it to play some music or something, and now here we are, where it's like, oh, there are personal computers.
Yeah.
So where do you think that's a decent analogy, or do you see, like, where do you think if that were the analogy, where along that path do you think we would be to the point where we get to the modern day? Here's an iPad, it thinks for you, and you can't break it.
I mean, 3D printers are weird because they sort of toe the line between tool and electronics, like computer peripheral, right?
Yeah.
So like, as an analogy to personal computers, I think it's tough because they're...
Well, like computers can be used to make things, as Shannon's sitting behind the editing board and we're making stuff, but computers can be used to like just play video games, right?
Yeah, whereas 3D printers, I mean, they can be fun, but you've always got to bring, like, you have to bring your creativity to the 3D printer to get anything out of it. There are, of course, online repositories of models you can download, but there comes a limit where you can only print so many, Yoda heads and twisty vases and things like that before you're like, okay, well, that was interesting, but now what?
So you're saying the onus is on the user, and in that, it's beautiful to see that we're now living in a day and age where these are actually in middle schools and high schools across the country.
Right. Yeah, totally. I have a 9-year-old, and his concept of where stuff comes from is going to be totally different than what my concept of where stuff comes from was, because stuff comes from the store. If I want a thing, I go to the store and I buy it. Like for him, it's like, well, stuff comes from the printer. If I want a thing, I go to the computer and I model it and I print it. Yeah. Like, so.
Dream it up.
Right.
The stuff comes from here, and then you just have to realize it.
Right. You just have to tell the machine to make it. And so 3D printing fits in with a bunch of other tools too, right? Like, CNC machining and laser cutting and all those different tools that are in makerspaces. Pick and place machines, and the ability for the next generation to basically realize their creativity is just on a whole other level. And I don't think we're going to really see that. Like, that's not playing out yet. It's starting to.
What do you think it's going to take to see that? Is it just a matter of time and adoption?
I think it's just the kids have to grow up. The kids that are using all this technology in schools, they just have to grow up. And the world is going to change.
See, that's exciting, just to know that our future is going to be bright and beautiful because kids are growing up with 3D printers today.
I'm such a rose-colored glasses kind of guy.
I am too. I feel that. You can't buy into the. Don't be a naysayer.
Well,
yeah.
There's a little sarcasm there. I mean, there's a lot of bad stuff going on in the world right now, so we got to deal with that too.
Yeah, but let's think about the wonderful things that are happening because kids are printing 3D Yodas.
This is true.
Yeah.
I mean, my kid printed like a little robot the other day.
Yeah.
And he was so proud of it, and he's has it sitting next to his bedside table, and he just thinks it's the coolest thing in the world, and it means so much more to him, this little robot, because it came from his imagination.
Right. It's kind of like the Lego, where it's like, okay, well, here's some bricks, but it's not a thing until you put it together, and then you have that attachment because it's your labor that went into building it.
Yeah, and so that's,
your creativity.
stuff, like obviously we've all got tons of stuff. And we go to the store and we buy stuff and it's cheap and it was made somewhere else by somebody we've never met. And it doesn't mean anything to us, right? And so when it breaks, it goes in the garbage. But if you made that thing and it breaks, you're like, well, but I liked that. That was my thing. I made that. So there's, like, I think ultimately, we're heading towards a place where stuff is made more locally, and it means stuff. It means something to us, and so we fix it. We modify it, we change it.
So this has a much bigger impact than just like, hey, making 3D printing accessible. You're talking about just like changing the whole mindset of society in terms of like where things come from, and our attachment with things, and changing the whole concept of consumerism.
Right, it's
the culture of ownership.
I mean, the whole, like, some of the tenets of the RepRap movement was democratization of manufacturing.
That was the tenet of podcasting when it first started in 2005. It was the same kind of concept that was born out of that.
Yeah, and I mean, it's headed there. I mean, we have customers that are buying 3D printers and starting businesses around them. And the cool thing is when you buy one printer, you've got the capability to make X number of objects a day. You can double that output by buying another printer.
Or or 3D printing another printer.
Or 3D printing another printer. Right.
Oh totally. Man, that's exciting. Cool. Well, if people don't want to 3D print a printer and just want to get a printer to 3D print printers, where can they get printers?
Well, ulzbot.com. Yeah, just head to ulzbot.com and you can learn all about our company and what we do.
That's cool. Yeah. Hey, Ben, dude, thanks for coming on. This was a lot of fun. I know we could go on all
great.
Day.
Yeah.
Maybe we will and put it in the B-roll. But anyway, for more, just check out ulzbot because these guys do great stuff.
Thanks.
If you have a great idea, bring it to the web the way Shannon and I do and head over to domain.com. With an awesome domain discovery service and a quick and easy checkout process, you'll have the perfect site up and running in no time. And the guys over at domain.com are huge Hak5 fans, which is why HAK5 will save you an extra 20% at domain.com. Or just send them a tweet and say thanks for supporting Hak5 all these years. So, when you think domain names, think domain.com.
On Hack Across America, hang on. That's right, we need to get our ugly holiday sweaters on, don't we? The uglier the better.
Yep.
Yeah.